All right, looks like we're good. So yes, we will talk about bad tests running wild and concurrency and test data and low human interaction. Lots of stuff intertwined there because of where software delivery has been wanting to go. But before we actually get to all of that, we'll do the quick introductions. So my name is Paul Grizzaffi. I'm a senior QE automation architect at Vaco. I've spent my career focused on automation and automation related activities. I'm an advisor to the graduate school and the advanced research program for software testing and QA at the University of Texas at Dallas. And I'm equally comfortable talking about test automation and Slayer. So if you've got any desire to talk about either one of those things, y'all can contact me at one of these locations. And the link on the bottom there is where I blog my hopefully cogent thoughts. So since we're a little pressed for time, we're going to jump right in here. And one does not simply walk into test automation and automate it. It's very tempting. There's the button or the click box or the YAML setting that says run concurrently or run in parallel. And it's difficult to get that to happen other than just pushing that button. There are a lot of extra considerations we need to think about before we can be successful in our parallelization or concurrency endeavors. So we're all familiar with the notion of the intermittent failure, right? Yes, the failures that happen sometimes and then they don't happen other times and are difficult to debug. A test report might look like this, and then a subsequent one might look like that. Yep, intermittent, all right. We're getting passes and fails. So where do these intermittent failures come from? There are three major categories. We'll get the first one out of the way, right? The flaky tests. Yes, sometimes we write our automation in a way such that it doesn't behave consistently with the app. A lot of times that will come from improper weighting or missing that there's a particular condition that is valid in the product, but that we haven't taken care of to handle in our test automation. Absolutely. A lot of people out there talking about flaky tests. Google it. You'll find good and bad answers out there. But mostly you need to rehabilitate your tests or understand that they're going to be flaky and use them as appropriate. I've got a separate conversation on that we can have another day. But sometimes we have flaky infrastructure. I worked at a company once where every now and then the QA environment, the app would just become not available, and you would have to hit F5 to refresh, and everything was cool. So I asked the person testing the software, I said, what happens here? Why are we just hitting the F5 to reload? What happens in production? Oh, well, we don't see this in production. So it was one of those, wait, do you not see it in production or does it not happen in production? Either way, flaky infrastructure certainly can cause intermittent failures in our tests. And then third, I know, right? Sometimes the application itself is flaky. Sometimes the issues in failing or infrequently failing test automation comes from the fact that the application itself is behaving improperly sometimes, but not all the time. So we need to investigate all these failures and figure these things out. So if we've got any amount of intermittentness or flakiness in our test automation, in our environment, in our application, turning on parallelization generally will not make that any better, and generally will make it much, much worse and harder to debug. So how do we handle some of this flakiness outside of the application itself? So I'll tell you a story in three different acts here. So the first act is the one about development. When you start talking about parallelization, there are the notion of threads and concurrent processes. So those of you with a background in software development and computer programming, maybe you went to college, or maybe you worked in a multi-threaded, multi-programming environment before, some of this will be a review for you. For others, this will be new and interesting, I hope. So threads, first, they're a lightweight way to run multiple code flows at the same time. So in other words, you've got one set of code and Different executions or threads can be happening in that code at any one time, giving you the ability to run things concurrently. It's super powerful, but it can be problematic because if your code is not thread safe, and we'll talk about thread safety shortly, you will have collisions and issues. You will see intermittent failures or different behaviors from time to time that can be extremely difficult to debug, even for experienced threading programmers. And if you depend on third-party code, either from a vendor or open source or from another organization inside of your company, that code will need to be thread safe as well. Because if your code is thread safe, but the code you're using is not thread safe, in effect, your application, your code base at that point is not thread safe, and you can have threading problems. So similar to threads, they're the notion of concurrent processes. So it's much heavier weight than threads. Threads are fairly lightweight in terms of memory and other system resources, whereas concurrent processes are a bit more heavyweight because instead of having basically one process with multiple execution flows, you'd have multiple processes doing a similar job. It does not entirely eliminate external entity dependencies, right? So you may handle some of your programming issues that way around shared data internal to your application, but not necessarily external. Because if both of the processes need to write to a database and there's a race condition about who writes first or who writes second, you're still going to have that problem even in concurrent processes. So in order to handle all of this, we need to make sure our code is thread safe. The idea of thread safety is that you can safely manipulate the data constructs in your code, even when multiple execution entities are acting at the same time. There are several methods to handle this, and I know in the interest of time, because we've only got 45 minutes, including questions here, I'm going to name them. There's a whole lot of good information on the internet out there. You can go and Google and find some pretty good explanations of these types of thread safety and what these individual items mean. But reentrancy basically means that your code can re-enter itself. Multiple flows can hit the same part of the code without interfering with the other part. Mutual exclusivity says only one of us can be interacting with this part of the code at a time. Atomic functions means that my entire function, my entire routine, or my entire code block must be completed before I get interrupted. And then immutable or unchanging objects, if your objects are read-only and they're set exactly once before concurrency happens, you can't really get into a thread safety issue there because everybody's reading the same piece of information. You can think of that as sort of like a constant that you're setting in your program. You set it once at the beginning, and then everybody can read it with no problems. So I'm getting dinged here. Is that one of the moderators dinging me? No?
No, not us.
All right, cool.
Yeah,
thank you.
It might be somewhere else in your house, man. I don't know.
No, it's probably on one of my other 50 programs I have running here. So thank you.
Go for it.
So you're a great multitasker.
Let's not talk about that. I'm not paying attention to y'all right now. Okay, but look for thread safe data structures and libraries. Like I said before, if your third-party libraries are not thread safe as well, then your entire application is not going to be thread safe. And we have to be aware of something called deadlock when we start handling reentrancy and mutual exclusivity and such. We'll talk about that more in a minute, but before we get to deadlock, we need to talk about race conditions. Now, a lot of times we'll talk about a race condition as a bug. A race condition in and of itself is not necessarily a bug, because what a race condition is, it's something that occurs when events can be received in a non-deterministic order. So handled race conditions are part of event-driven programming, GUI programming, anything that's going to handle asynchronous activities. Race conditions are there. Can operation X happen before operation Y? Can they happen in the other way? If they can handle in either way, it's certainly a race condition, But if your code handles it in either order, you're good. But if X has to happen before Y, and you don't handle what happens when Y happens before X, you can get bugs and issues that way. It's the unhandled race conditions that lead to these intermittent failures or deadlock. And again, I promise we're going to get to deadlock. But to give an example, something visual of a handled race condition, we'll go back way to the before times when I first started my professional career. I worked at a telecommunications company. And this is a very rudimentary example of what happens during a phone call. So you have two parties in the call, the caller and the callee. And the caller calls the callee and says, hey, how you doing? You want to go get some pizza or whatever? And then when they're done talking, the caller hangs up first, and then the callee hangs up. But this is a handled race condition in a defect-free telecommunications network. Because if the callee hangs up first, says, man, I'm so mad at you, I'm not going anywhere with you, and hangs up before the caller hangs up, the system still needs to handle that and clean up the pieces so that we don't have resource contention or resource and memory eaters as we go. With the unhandled race conditions, because in a phone call, either side can end the call first, or even at technically the same time. So if we're counting on the caller to end first, well, the system will clean up the callee side. But if we're counting on if the callee hangs up first, then we'll have some sort of an issue over on the caller side where, again, maybe the system resources aren't cleaned up, and we're going to get stuck in issues where eventually we will run out and we will have crashes or problems, or we have to do some restarts because we'll get into a condition called deadlock. And deadlock is when no entities in your system can continue processing because each is waiting for a resource that's held by the other. So what's that look like? Suppose we have two entities that need the same resources. Let's say we have two different threads or processes that need to access two files at the same time, and it's the same two files. So we've got entity one, entity two, and they each need to interact with resource A and resource B. We can get into deadlock if entity one grabs resource A before entity two does, but entity two grabs resource B before entity one does. Now we're in a situation where they each have one of the two required resources that they need. They can't get the other one. So if the system is not set up to handle this type of situation, timeout, failure, getting all your resources at once before you get any of them, if your system doesn't do that, then you can get into a state where eventually nothing else can happen in your system because everything is blocked waiting on something else. Now, you've heard me say the word application a bunch of times here, so you're probably scratching your head. Is this for programmers? Is this for testers? Is this for automation people? What are we talking about here? Are we developing an application? Well, no, we're not developing an application. Okay, yes, kind of we are, because if you think about it, whether we're using drag and drop or record and playback or code or some blend of all those things, we're developing software. And the automation development is software development. We have to treat it as such. And sometimes treating it as such means some of that development may need to be thread safe. So we have to understand these notions of shareability, exclusivity, when we're working in a parallel environment where we're running more than one test case at once. All right. Now we're going to go into the act about configuration, because that was the programming part. The quick moral of the first act is if you don't write your code such that it can work in parallel, it's not going to work in parallel. And if you've already got intermittent failures that are potentially caused by conflicts and unhandled race conditions, turning on parallelization is only going to make it worse. And instead of a 3% failure rate, you're going to have a 40% failure rate or something like that. It's going to be significantly different. So if you're going to start doing parallelization, make sure your code is thread safe. So when we talk about configuration, there are all sorts of parts of our system configuration and test data. Credentials are a big thing. Do you have enough credentials to do all the testing that you want to do in parallel? If you want to run 100 test scripts in parallel, do you need 100 different credentials? Depends on your app. If your app requires logging in, you might need 100 different credentials. Unless they can be shared. Can one user be logged in 100 times? If so, okay, that's cool from a credential standpoint, but what about from a test data standpoint? If I'm running 2 different test scripts, one where I add something to a wish list and one where I take something away from a wish list, does the order in which those run, does that give some sort of a problem in what the test results would be and whether we get some intermittent failures just based on we stepped on the data that we were trying to use? And then how hard is it to obtain obtain unique credentials? Some companies, some apps, it's easy. You go in, you provision, I need 100 sets of credentials. You spend 10 minutes doing it, and then you got 100 credentials, no problem. Other apps, other companies, other organizations, they tie it into third-party authentication and authorization products, or it's tied into your Active Directory system or something along those lines. Getting additional credentials there can be problematic for many different reasons. One is security doesn't typically like for people to have more than one ID. And when there is an ID, they want an actual human being associated with that. And it's not a shared resource where more than one person uses the password. So there could be some friction there for you to get all those credentials that you need. She worked with a client once where they were about to run out of credentials because they had a set way of what their credentials were, and they built some logic around that in certain of their data storage areas. They grew so big that they started to run out of IDs, and they were going to have to do something to resolve that. So I chuckle a little bit because it's one of those, boy, man, I'm glad it wasn't me, but that's not a funny problem to solve because it was going to be a large and potentially expensive endeavor to resolve. So there may be other similar scenarios in your app, right? I just pick on credentials because it's one of the easy ones and it's one of the ones that we tend to run into first. But there may be other types of constrained resources or potentially constrained resources that you need to have unique or individual instances of so that your tests don't collide with each other. And then I talked about that being part of the data, but there is the actual data, what we normally talk about test data as well. Because in general, managing data is just a pain. Just is. I have not seen a good sort of canonical way to manage data because every system handles the data differently, configures it differently, different databases, different schemas, different tables, all that stuff. It just has to be handled in a way that is productive and sufficiently economical for your environment. Each concurrent test script might need its own data, might need its own account with its own data, with its own set of orders or tickets or flight plans or whatever it is, especially if the data can be transient. In other words, your data necessarily goes from new to in process to boarding to in flight to landed. If that's the sort of hard-coded workflow in your system, it can be difficult to reuse data because you'll have to go and reset it. If you are going concurrently, you don't really know when to reset it. Inattention to test data can cause intermittent behavior. If you're accidentally trouncing your data, your test cases are running in parallel and they're stepping all over each other, you're going to have intermittent failures because you can't guarantee the order in which they're going to execute just by the nature of them being concurrent. Oh, and then there are the execution environments. So we've got all the stuff we want to execute. Where are we going to execute it? You're going to need more horsepower. You may not need, significantly more horsepower if what you're doing is you're testing a bunch of API calls, a bunch of REST or SOAP or a bunch of calculations to a library that your company's built. Parallelization there probably is going to be relatively cheap compared to something like GUI testing. You want to run a bunch of things, a bunch of test scripts in parallel for GUI testing. You have other types of constraints there. One certainly is horsepower, but sometimes for certain apps, for certain browsers, there are issues running more than one instance of that browser or that app on a single machine. So as soon as you want to go parallel across your GUI applications or the GUI portions of your applications, multiple machines or devices or virtual machines or whatever, they're going to become much more critical. And we're going to start talking about price increases, because none of the things I've talked about here are free. You either have to have taken care of them already, so your development was probably a little slower, maybe a little more expensive upfront, or you're now going to have to undertake a project to make your tests and your system and your environment concurrency friendly. For GUI testing, however, there are alternate approaches that could be economical for some clients in some cases. Cloud-based grids and device farms can certainly take the sting out of some of those cuts, but of course it does come at a cost. Are you going to handle it yourself? There's a cost to doing that. You're going to handle it, go with a cloud provider partner. There's a different kind of cost for that. And then tool support. I don't think this is quite as big a deal as it was 10 years ago, or even say 5 years ago. But does your automation tool even support parallel execution? Something to check out, and also check out how it implements it. It may say, yes, I can run these things in parallel, but it may be restricted or restrictive in what it can allow from a horsepower standpoint or a licensing standpoint. Hey, I want to run in parallel. Do I need one license per parallel instance? If so, is there a difference between a runtime license and a development license? Is there a cost difference there? Sometimes you may have the horsepower to go faster, but maybe you don't have the money to go faster, or to go as fast as you would like, just because of the cost of working with licenses and hardware and all these other things. And can you run it parallel on a single machine? Is it even going to work that way? So it sounds like I'm saying, man, don't parallelize. Do everything sequentially. Kind of. If you can do everything sequentially, you're going to have fewer problems and probably incur less dollar outlay for that. But there's a downside to that. It's going to take you longer to get your feedback, because instead of running 5, 10, 100 at once, you're going to have to wait for each one to execute before you can find out if the whole suite gives you the information you need about passing and failing and intermittency. So I always say parallelize appropriately. Those of you that have heard me speak before, appropriate is a word that I use a lot. Responsible is a word I use a lot. Parallelize appropriately, because automation only needs to run fast enough. It doesn't need to run as fast as mechanically possible or electronically possible. It needs to provide you the feedback in a valuable way, in an amount of time that is tolerable and digestible by your organization. So don't over-engineer it. Don't overthink some of the things you're doing. Start with what's appropriate and then evolve. One of the things that I've done and I've seen done is, okay, we're not in a position to untangle all of our tests from each other, not because the tests rely on each other directly in code, which is a big no-no, but because we can't get enough credentials, or because we can't get enough test data for whatever myriad reasons are out there. I've seen teams administratively run in parallel. In other words, I have 5,000 test scripts that I want to run largely in parallel. Well, I can't do it. But I know that these 100 can run in parallel with anything. So they're free radicals, right? They can go out, we can put them in anywhere we want. I have these other 10 that are highly dependent on the data setup. Perhaps they need to run sequentially, but they can run in parallel with the other 100. And you can break down your suites and your plans and other things that way, configure them such that they run in sequentially within that set, but across the sets could run parallel. then you don't have to worry about threading and a lot of these other things. All you have to worry about is understanding, can set A adversely interact with set B or vice versa? If the answer is no, then they can run in parallel, generally. And we did this at a company I worked at. And a lot of times you need to start with what you have. You got to dance with what brung you, right? You've heard that expression. So this is an old automation lab that I had. Some of you may have seen this picture before, but basically it's a bunch of old Core 2 duos running parallel automation in a conference room. I had 3 tables like this set up in there. Boy, it was really hot. Those things put out a lot of heat. But what we did was we administratively parallelized everything. We could run each of the conference tables could run in parallel with the other, but each conference table, everything had to run sequentially. So we would set up the boxes to run sequentially that way. And then Act 3, the one about risk, because every time we talk about parallelization, or most of the time when we talk about parallelization, it's about going faster. I want to get my testing done faster so that I can release faster. So risk is there. Now, is this a good risk? Right? I assume that's a Photoshop picture, but you never know. Or it could be in Louisiana and she's shopping for dinner. We eat alligators down there. So this is probably a bad risk here, having a small child next to an on-land alligator with no barriers or anything. But sometimes we have to take risks and figure out, are they tolerable for us as a team, as an organization, and as a company? Because if the risk falls through, then we're going to have some sort of cost or damage or liability that we're going to have to recoup from. So we have to understand and manage our risks appropriately. Parallelization. What we want to do ultimately is get everything to run fast enough that when a dev checks in an app change, it can go through all the hamster wheels and the plumbing and the pipes and the mallets and everything, and it gets out to production, and boom, within minutes, it's there. There's a big desire from a lot of companies to do this. And I'm not here to tell them whether or not for them that's the right thing to do. But in general, there's some risk there. And in order to de-risk this, you have to go what I call too low. A low cost of change and a low cost of failure. If your change is expensive, you probably need human eyes before you roll out a release. Like, for example, I worked at an e-com company once, and rolling out an update to the POS system was very expensive in terms of time. If there was an issue, if a bug was discovered, it was quite expensive, and there was a lot of heartburn that went around to get the bug resolved and then get that pushed out to all the 5,000 or whatever stores that we had at the time. So the more expensive your change, the more testing you're going to want to have, and the more rounded testing you're going to want to have. You might not want to trust everything to just the machines. And if your failure is expensive, you might need human eyes as well. Think about the difference between an e-com app and an embedded software in a pacemaker. Well, if the e-com app fails, yeah, you might owe somebody some money. You're going to get a little bad press. You might have to send something for free or give some discounts or something, but nobody died. What happens if your pacemaker software has a critical failure in it? The cost of failure there is really high. Cost of change here is going to be expensive too, most likely, but certainly the cost of failure is high because now you're at risk of loss of life. But most of us don't live in either of those worlds where it's all of one is, they're both expensive, or neither's expensive, or one's expensive and the other's not. We all live in these different types of worlds. So we have to look and see what we, as an organization, as a company, are tolerant of. If each has a tolerable expense, you probably still need human eyes at that point, simply because who's using your software? Is the user of your software another computer? In most cases, probably not. There's at least a transitive relationship between the piece of software you're working on and a human being that is using your software or the software your system runs in. So you probably still need human eyes because humans are still the ultimate end users in almost all software right now. But you might have manageable or appropriate risks, again, that your company can tolerate to say, we're okay because our risk profile is sufficiently small in both cost of change and cost of failure that we can go without human eyes on portions of our software or even all of it. We're okay with that because we're ready to absorb the impact of that. There's risk there. But again, I'm not the one that's going to tell the world in general that it's categorically a bad idea, but it is risky. So in order to understand and manage your risks, you need appropriate logging from your test automation. So when we think about product, when we think about software, what's the outcome? What's the output of using the Amazon app? Is it an order number? No. Ultimately, it's something appears magically on your doorstep. And that's sort of the dirty open secret of the software development world. Nobody wants software. I mean, people like me do because I like writing software and fooling with software. But ultimately, the person that's in, at their house and said, man, I'm out of laundry detergent. I want to think really hard and have it magically show up at my door now. Well, we're not there yet. We'll probably never be there. So the closest we can get to a frictionless experience there is to whip out our omnipresent mobile device, click on our provider of or our retailer of preference, say I want my laundry detergent, and then it will show up some hours or days later. Test automation as a software package is different. What we're getting out of test automation is information, and we need the information to help us do our job. So we need the logging. You have to think of the logging as a trail of breadcrumbs that can reduce your cost of change, reduce your cost of failure, and show you what your system did, what your test system did or didn't do during a particular execution cycle. Makes it easier to go back and debug some of those intermittent failures, whether they're based on threading and concurrency or not. So unattended execution, which most of us are moving toward, right? We're putting it in a pipeline, whether we're pushing to production immediately or not, we're running stuff unattended. And then we are later going back to triage those results and use them for further information about the quality of our system. The logging is so much more important in that because you're not watching what's happening. Plus, when you get into hundreds of test cases, nobody wants to sit there and watch hundreds of test cases execute. So unattended requires more and better logging. When I talk about logging, I talk about the three ables of logging: available, applicable, and understandable. If the people who need the logging information can't get it, it's not available, and you're not going to be able to do your job well. If it's not applicable, if your logs are and reports are huge and voluminous, right? Because we're logging everything just in case, it's going to be harder to do your job there. The more applicable the information is, even if it requires you to log everything and you put some filters in place so that frontline testers can do something, and then maybe dev people can do stuff, and SDETs can do different things based on that same data with different filters, you got some really powerful stuff there. And they have to be understandable. The logs have to mean something to everyone who is triaging them, using them to do their job. So getting them in a jargon that is friendly to everyone is very important because it's going to cut down your cost of failure, because it's going to cut down the amount of time it takes you to go from a failure to figuring out what that failure was. And then review your logs just the same way you review your code. We do review our code, right? So review your automation code and review the logs as well. Run it and evaluate what happened. Did you get the information you expected? Did you get information that is good enough for you to do your job and say what that test script or that set of test scripts did or did not do? Then make it fail. Did it tell you what it didn't do? Did you understand the issue? If not, we go back and evolve. as we figure out the things that we need for failures, to understand what the system's doing, to trust the system. If we don't trust our test automation system, we're not going to use it, or we're going to use it and then we're going to go and redo some of that work in a different manner. We have to build the trust. The way to build the trust is to understand what it's doing. One way to understand what it's doing is through logs and reports. So I'll wrap up quickly and then we'll take some questions. Thread safety. If you're going to parallelize, you probably have to be thread safe, depending on how your tool is implemented. But certainly having appropriate environments and appropriate data, regardless of the implementation of your concurrency, those are going to be there and they will always be there. And you can trash your concurrency endeavor very quickly by not having appropriate data. Enough credentials, definitely related to appropriate data, but often has a separate layer to it, which is interacting with third-party teams like partners or security teams to figure out, okay, how do I get more of these credentials? And then if you really want to do things like commit to production, you're going to have to go too low with a low cost of failure and a low cost of change. And now I can take some questions.
Okay, great. Thanks, Paul. That was great. I see 2 questions coming in. So let's start with the first from Barbara. Okay. Barbara says that parallel testing requires a lot of computing power. How can smaller organizations or those without a strong infrastructure to support it make sure that they're really covering all their bases?
You probably can't. If you, I mean, just to be blunt, if you can't afford additional hardware, additional processing power, additional environments, whatever it is you need to go in parallel, then you can't go in parallel. What you'll have to do is either change the expectations or change what some of your implementations are. If you're needing to go in parallel because individual test scripts are taking a long time, multiple minutes, well, evaluate why they're taking multiple minutes. Does it take multiple minutes if a human does the same thing? If the answer is yes, then perhaps you need to figure out ways to break up your tests into smaller units so that they could be parallelized on less hardware. But if it takes a human significantly less time, or at least appreciably less time, than it takes your automation to execute, it's not necessarily a problem, but it does indicate something that is worth investigating to say, okay, why can I do this by hand so much quicker than the test script takes? Do we have some hard-coded weights that don't need to be there? Can we change that? Is the tool we're working with, is it just really incompatible with some of the systems that we have here? Is the test environment? Yeah, my desktop, I've got, 16 cores and 64 gigs of RAM. But on my test environment, I'm running in a VDI that's got 2 processors and 8 gigs of RAM. That's certainly going to slow things down in most cases because you're just fighting for resources at that point. So you can look more at your hygienic environment to see if there are things you can trade off there. If you can't add horsepower just because of finances or space or whatever it is.
Okay, yeah, that makes sense. All right, and the final question, I'm sorry, I can't see this gentleman's name very clearly, but the question is about multiple test cases running simultaneously. He says that each test case may require specific kinds of test data, and managing that and making sure that test data is available can really be difficult. What kind of advice can you give to make sure that, or to help him and others like him really stay organized and do that effectively?
Yeah, sure. Unfortunately, this is another one there's just no magic answer for it because everybody's environment's different. Your product's different. Your people are different. The hardware you have, how your implementation is, it's all different. The biggest piece of advice I can give is for new endeavors, new products, greenfield stuff, or new components and features being added to existing products. work with the development teams and the architects and whatever to say, we have to make this not only testable, but automatable. And the way we need to make it automatable, one of the ways is we need to be able to blow data into the system, blow some bits and bytes out there to put it in a specific state and then execute. That's not always feasible, especially with these transient types of things like airline reservations and all, but it's certainly probably more feasible than what we have out there today. So as soon as you make it where you can interject sort of, I don't want to say arbitrary, but you can interject the appropriate data at an arbitrary point in at a typical workflow, that gives you the ability to jump to that part of the workflow, which sort of helps a little bit of the previous person's question. But also here, what it's going to do is it's going to take going from this mammoth amount of test data that you have to have potentially uniquely for each different test case to maybe you don't have to have it all as one sort of monolith. You can break it up and then potentially reuse it, making some of that management more manageable, but some of that management more digestible and more economical. But really, the big advice here is look at where you're spending your time, and then work with the larger ecosystem, the people that deal with your hardware, the people that are delivering the software, your project managers, your security people, all of that, and figure out how can we make this less expensive? How can we make this such that it takes less effort? Because chances are you're not going to be able to do a whole lot on your own, just as a test team or an automation team, simply because all the systems are so interdependent these days.
Makes sense. And I think the idea that you just touched upon about saving money, saving time, I don't know any organization that doesn't have that top of mind. So certainly relevant. A third question just came in from Umar Khalid from the UK. Umar is asking, parallelization in CI/CD or cloud is better, or having your own physical infrastructure? I guess the question is, what is better?
Green. There is no better. There's only more appropriate or less appropriate for your environment. They obviously have different economic models, different maintenance models, different effort models. Certainly with your, I mean, the big device division you might look at there is, if it's mine and it's on-prem, then I get to do every bit of it and configure it and tune it and do everything exactly the way I want. Whereas if it's on your physical premise, then you have to do that, right? You're obligated to do that. Whereas some of that stuff is a little bit more commodity, and perhaps you can get some economies of scale or some economic value by putting that in the cloud. So there's no right answer to that. There's only an answer that is more or less appropriate for a given organization, team, or company.
So they really have to consider strongly their own needs and what best suits, whatever.
Absolutely.
Okay.
Absolutely.
Great.
Now, other people will probably have different answers to that question. That's my answer.
Okay, wonderful. Umar just sent you a thank you, so he appreciates your answer.
You're very welcome.
Okay, well, if other questions come up, we'll definitely pass your way. Feel free, everyone watching, to go ahead and send any other questions Paul's way. And without further ado, I think that brings our final session to a close. So thank you so much, Paul, for sharing those insights.
Absolutely. Thank you for having me. Thank you, everyone, for your time.